So basically, this is the course of bioinformatics software development, and we will start by this and discussing about the system development lifecycle. And yeah, so let's just start. So traditionally, the system development lifecycle, which it is also called as SDLC, it is commonly used to design products, and normally we divide the process into three parts: the requirement analysis, data modeling, and normalization. So during the first phase, which is requirement analysis, the development and the design team normally conduct interviews so that they can capture the business needs which are related to the product proposed system. So the purpose of whole activity is to uh, capture what actually is required for that particular proposed system, and what are the actual needs of the you can say people in here or end users. So the data modeling phase, which is the second phase, normally consists of creation of logical data models that will later be used to define the physical data models or database structure. So data modeling is performed logically and physically. So first it is done on, on the basis of logic of the you can say business needs of the users. So people used to create some flow diagrams or some entity relationship diagrams to fulfill this particular process, and then the actual physical modeling of the you can say whole process takes place, which include database design, maybe some other programming paradigm. So after the database has been modeled and redesigned, designed, the normalization phase is implemented to help eliminate or reduce as much as possible any redundant data. So after all the things has been done, database has been designed, your front end, back end has been tested. So normalization phase is normally carried out so that if there is any redundancy in attributes or in entities or in processes, that redundancy can be, duplication can be removed. So these are these are the three phases or parts, not phases, in fact, parts of the SDLC. But overall, there can be many subphases in each of them, which we will discuss in the coming sections. So the development phase, let's discuss about development phase first. So the development life cycle includes four overall components. Uh, Using this perspective, development would consist of all necessary steps to accomplish the creation of the application. This includes feasibility, analysis, design, and the actual coding. So these are the four components that need to be there in order to for the development process to be comprehensive and complete. Feasibility, among all these four, feasibility, which represents the tasks necessary to determine whether the software project makes business sense. So obviously, in order to for the developers or the team to implement an idea, first it need to make sense, and the organization must understand that the business idea they are proposing, they it can be a real thing on the ground. So feasibility actually is make sure that you are taking right steps in the right direction at the right time. So most organizations would integrate the process of return on investment during this step, which is also called as ROI. So ROI consists of financial steps that determine mathematically whether the project will provide the necessary monetary returns to the business. So you're invested. Normally, organizations invest in some project so that they can benefit from it. So normally, some organization, when some organization is proposing a system, they are trying to. They also are interested in what will be the return on investment, how they will benefit from it in the longer run, financially, administratively, or any other way. So what is the return on investment? So basically, return on investment consists of financial steps that determine mathematically whether the project will provide the necessary monetary returns to the business. So among all the benefits that the project will give to the organization, so the monetary or money-based, you can say, returns benefits are the most important, and you have to provide some mathematical facts and figures to support your idea. Focusing solely on monetary returns can be a serious pitfall, and so this can be a serious pitfall since there are many benefits that can be realized by non-monetary returns. So feasibility often contains what is known as high-level forecast or budget. The high would represent the worst case scenario on cost, and the low, the best case or lowest case. So normally ROI is a very integral part of, or important part of feasibility, and normally it represents a very high level detail of how the budget will be look like, and what are the best worst case and the best case scenarios in both of the cases. The hope of the chaos is that the actual cost and timetable would fall somewhere in between the high and the low. So this is the ideal scenario where you don't have to compromise between the two. There can be worst case scenarios. There can be best case scenarios. So the ideal case is that you lie in the middle of some of these two extremes. Feasibility can go beyond just the budget. It also represents whether the business fees that the project is attainable within a specific timetable as well. So feasibility is a statement of both financial and business objectives and an overall belief that the cost is worth the payback. So feasibility is very important before the start of the actual project, before the start of analysis, design, or any other coding or development, you can say, activity that can be carried out on that particular project. So taking feasibility is the first step, or having a good feasibility report is the first step towards a particular software or any, in fact, project. Yeah. So the second important phase after you have a sound belief or sound, you can say, footings in a feasibility that you should go for that particular project. Analysis is then the next phase that you need to focus on, and analysis is the ultimate step of creating the detailed logical requirements or the architecture of the applications and database. Ultimately, the analyst, which the analyst is the person who normally carries out the phase of analysis. The analyst creates a requirement document that outlines all of the needs for the coders to work from without going back to the users directly for clarification. So normally it is the job of the analyst to create such document that the designer guys and the development guys like coders, programmers, they can rely on those documents and they can extract the necessary information from those documents and transform the you can say user requirement into the reality. Analysis as an architectural possibility responsibility is very much based on a mathematical progression of predictable steps. These steps are quite iterative in nature, which requires practitioners to understand the gradual nature of completion of this step in the development. Another aspect of the mathematical analysis of the whole analysis phase is decomposition. So decomposition, as you can see, that establishes the creation of smaller components that make up the whole. So we tend to divide the whole process into smaller components of subphases, and this can make the things easy to understand for the designers or programmers, and in the long run, it can benefit them. So it is like just birds, bones, and muscles of the human body that can ultimately make up the whole body and a person. Once the system is decomposed into the smaller components, the analyst can be confident that the parts that comprise the whole are identified and can be used throughout the system as necessary. These decomposed parts are called objects and comprise the study and application of object-oriented analysis and design. So the basis of working with users ultimately lead to the creation of parts known as objects and act as interchangeable components that can be used whenever needed. So, so you can think that objects can be interchangeable parts of the card. They sometimes are called standard parts that can be used. They can be used in multiple models. So the benefits are obviously very big, and such is the same objective with this software. The more reusable, the more efficient and the cost effective will be. So the purpose of this whole analysis phase is to streamline the process by collecting the data and streamline the data in the form of some logic and then in a way that the intricate parts are visible and that they can be seen as a logically connected with one another without the doubt of being duplicated in a certain you can say scenarios or phases. So design then the design phase. Design is far less logical than analysis, but a more creative step actually, because we are actually relying on the information or models gathered or information gathered on in analysis part. So basically, we are more of like creative on the creative side. So design is the phase that requires physical decisions about the system, from what programming language to use, which vendor database to select. So these are the decisions you have to make during during the design phase of the development stage. So basically, which languages you are going to use to build that system, which database vendor will be selected, like Oracle, Sybase, DB2. So how the forms and reports will be identified. So these are all the things then need to be, you can say, clarified during the design phase. And so it is more of like a creative step rather than an analysis step. So the design phase can also include decisions about hardware and network communications or the topology actually. Unlike analysis, design requires less of a mathematical and engineering focus to one that actually serves the user review. The design process is perhaps the most iterative, which could require multiple sessions with the user using a trial and error approach until the correct user interface and product selection has been completed. So design often requires experts in the database design, screen architecture experts, and as well as those professionals that understand performance needs of network servers and other hardware components required by the system. So this all comes into the design phase from hardware to software needs of that particular project. Then the next phase is the coding. Coding is very straightforward. It represents the actually it represents another architecture as well as mathematical approach. But you can say actually architecture more of like, because it transforms what has been designed in the design phase. This combinatorial mathematics is known as Boolean algebra, or the mathematics of the logic. Boolean algebra is the basis of how software communications with the real machines. Normally, it is in the form of 0, 1, and software is a physical abstraction that allows us to talk with the hardware machine. So, so coding then is the best way to actually develop the structure of the program. Much has been written about these coding styles and formats, and you also know about structure programming and object-oriented programming. Structure programming normally was originally developed so that the programmers would create code that would be cohesive, and they are self-reliant. And here, from a self-reliance, we mean that coding and the program is self-contained because of all of the logic relating to its task is within the program. So normally the downside of such programming structure is programming paradigm is that it is mostly not reusable, because all of the things are integrated within one program, and the individual components cannot be distinguished into separate blocks, and they cannot be reused into some other script or program. So opposite of cohesion is coupling. Coupling is a logical program that are reliant on each other, meaning that a change to one program necessitates a change in another program. So coupling is viewed as being dangerous from maintenance and quality perspective, simply because changes cause problems in other reliant or coupled system. The relationship of coding to analysis can be uncritical, given that the decision on what code will comprise a module may be determined during analysis as opposed to coding. So this is coupling, where coupling is actually another opposite that of you can say cohesive programming languages, cohesive structure of the programming. Coupling is just like you are using some component of the program in another program. So the problem here will be can be that when you change the original one, so it affects the other dependent scripts as well, which are using those scripts. So this is the coupling. Then comes the testing. Testing can have a number of components actually. Okay, first let me ask you that if you have any question until then, you can type in the chat, and I will try to answer that. So the next step is testing. Testing actually is a very big step, a very big phase, and it can have multiple components and steps and stages, you can say, or even the forms. So the first form of testing is called program debugging. So it is very simple. Normally, whenever you write a program, you normally go through debugging process a lot. So debugging is the process of a programmer ensuring that his or her code is in a program executes as designed. Then whatever you are designing or want the program to do. Debugging, actually, you do a lot of debugging in order to make it that way, and you need to make it function like that. So debugging is actually it is that process that program you as a programmer try to make that code work. So debugging can should be carried out by the programmer actually, because programmer knows his code, or whatever he has written, how he has arranged the individual components or subcomponents of the program. So software quality assurance group, normally quality assurance guys or testing guys, they are not involved in this form of you can say testing. So debugging is normally carried out by the programmer himself. However, it is important to recognize that debugging does not ensure that the program is performing as required by end users, rather only confirms that the code executes and does not abort during program execution. So this is very important that normally a programmer debug the program so that it executes perfectly. There is no error in execution of the program or the compilation of the program, rather than whether ensuring that it is it fulfills the requirements of the user. So that is another story. So normally debugging is carried out by programmer so that he can confirm that the program executes. So this is the first form of testing. Um, So because this also makes sure that not only that program executes, but also makes programmer by debugging, programmer ensures that the program is not passed to the quality assurance team if it is not executing at all, at least showing that it does perform under all conditions. Once again, this process does not ensure that the results produced by the programs are correct or meet the original requirements set forth by the users. Once a program has been debugged, it should then be sent through the quality assurance process. So this in testing. This is the first step, that you debug the program. Then the next step is that um, you send it to the quality assurance process, team or process. Mostly in large organizations, they are focusing too much on quality assurance of the you can say the products, and this ensures that the product they are producing it is according to the requirements or wishes of the you can say of the end users. As a result, organizations create separate quality assurance departments, um, and they only test the products that are being developed in that organizations. So quality assurance organizations typically accomplish this by designing what is known as acceptance test planning. So what is acceptance test? Acceptance test plans are designed from the original requirements, which allow quality assurance personnel to develop assurance testing based on the user's original requirements, as opposed to what might have been interpreted. So it can happen during a lot. It happens a lot during the design, or you can say coding phase or development phase of the software. That the requirement given by the users are different, and the requirements interpreted by the programmers are entirely different. So it can result in a software which in a program or in a product which is totally not suitable for the purpose that user want to fulfill, and so it results in a bad product. So acceptance testing are actually for that purpose, that you try to you plan to test the product so that it can to confirm that it is according to the wishes and requirements of the user. For this reason, acceptance test planning is typically implemented during the analysis and design phase of the life cycle, but executed during the testing phase. So it has been planning acceptance test is very important, and it is normally implemented during the analysis and design phases as well, so that we can ensure that the correct interpretation of the user's requirement has been passed on to the analyst or designer of the product as well. Acceptance test planning also includes system type testing activities such as test and load testing that is being also carried out. or integration testing, which ensures that the whether application communicates or operates appropriately with other programs in the system, as well as compatibility testing, such as ensuring that application operate on types of browsers or computer systems. So this is compatibility testing. This ensures that the system works on a variety of the platforms. So testing by its very nature is it is very iterative process that can often create loops of redesign and reprogramming. Sometimes when testers by using a quality assurance, so we identify that the program is not according to the requirements and wishes of the users. So we go towards the redesigning or reprogramming of the entire system or some part of the system that has been identified. So this is very iterative or repetitive process. So it is important to recognize that acceptance testing has two distinct components. First, the design of the test plans. Second, the execution of those test plans. So this is about the, you can say, acceptance testing, which is the mostly the major objective or major testing activity that is being carried out during testing phase of the life cycle or software development life cycle. So I guess we will keep it this and if you have any questions, you can ask, you can type, and I will answer that.